Good morning, everyone. We'll continue our discussion on files topic, the last topic in our syllabus. So, yesterday we had the introduction that files are used for permanent storage of data, and files are stored in secondary storage normally, hard disk or your flash memory in your mobile, or in a USB pen drive, or in a CD, etc. So normally in our computer system, the main secondary storage device is the hard disk, and we store data in the form of files. And yesterday we had seen some functions which we are going to learn in this. So, opening fopen for opening function, opening the file or creating the file also fopen. Fclose is used for closing the file. GetC is for reading a character from a file. PutC is for writing a character into the file. Fscanf and fprintf, similar to scanf and printf, we can use fscanf for reading different types of data, integer, character, double, float, etc. Fprintf can be used for writing different types of data into file. This is for reading from the file, and this is for writing into the file. Normal scanf is for reading from the user, the keyboard data. Okay, so fprintf writes into the file. Here getW for reading an integer. If the file is containing integer data, getW is used for reading that, putW is used for writing into the file. FEOF is used for checking the end of the file is reached or not. While we are reading, after reading all the data, we will reach the end of the file. So that means all the data is read. So this function is used to check whether we have reached the end of the file. Okay, this many functions are there. And we had seen fopen, the format of syntax of fopen. It takes file name, which is a string, and a mode. File name is which is the file that needs to be opened, and mode says we are opening it for reading or writing, or reading and writing, or appending. So different modes are there. Both are string parameters. Since they are in double quotes, even though single symbol is there, one single character is there, when we are putting in double quote, it is treated as a string, not as individual single character. So both are string parameters. And we had seen one example program. This function simply takes a character from the user and it will write it into the file. Yesterday we had seen this. So getChar is the function used for reading a character from the user with the help of keyboard. Once it is accepted, we can write it into a file. So if I run this, I have to enter one character, so I enter maybe G. And if I go to the disk, this is my hard disk drive, and there is a file created. You can see the date and time. Just now it is created 11:58 AM. It is created, and if you go into that, it is G in that file. Okay, what we are doing is, in this program we get the character from the user, write it into the file, then again read it back. Using getC, we read it back and display it on the screen. Okay, so first in the writing mode we open the file. After that, after writing into the file, here the reading part, in the reading mode we are opening the file. Fopen, file name, read mode. So this is the workflow normally you will be using. You write some data into the file, read it back from the file if the data is already existing there, etc. And open the file, write data, close the file, again open the file in read mode, read data, display onto the screen. Okay, we'll now go into the functions. So fopen, you are already familiar, fopen. And what are the different modes available? The second parameter is mode, right? So the different values are available based on in which mode we want to open the file. So one is R mode, R mode means we want to open the file in read mode. And if the file is not there, it will return null. Null essentially means 0. So to indicate that the file is not there or not existing, this function will return null. So we are calling this function fopen, and we are assigning the return value to a pointer of file type. File is a user defined type, somewhere in the header file defined as a structure. Okay, and we are creating a pointer. Now when I do fopen, if it is successful, the address of the file or the address that represents the file is returned and stored in this. For all the subsequent operations, we want to read data or write data or close the file, etc. We don't need the file name anymore. We just need the file pointer. So the return value of fopen is null if the opening process is failed. Null stands for 0. But if it is successful, a valid address will be returned and that will be stored in the file pointer. And we use this file pointer, which essentially represent the opened file for any further operations. So read mode means the second parameter of the file fopen function. Read mode means file will be opened in file in read mode, open for reading, and if the file is not there or any error is there in the process of opening the file, value null will be returned. Okay, null is essentially 0. Now if you want to open the file in write mode, we specify the mode value or mode parameter as w within double quotes. So this will open the file in write mode, and if the file is already existing, it will overwrite. So if the file is the file with the same name is existing, then that will be overwritten by the new open call. Overwriting means whatever file is there, that will be deleted along with its contents, and a fresh file will be created. That's what overwriting. So read mode, if the file is not there, null is returned. When we are opening in write mode, if the file is already there, if file is not there, no problem, it will create a new file and open it. If the file is already there, that will delete the existing file along with its contents and create a fresh file and open it. So essentially, effectively what happens is the content of the existing file will be destroyed if the file is already existing and we are trying to open it in the write mode. Now if you don't want to lose the contents of the existing file, we can open it in append mode. Append mode means it will, if the file is existing, it will open the file and start writing at the end of the existing data. It will start writing at the end of the existing data. So write mode will destroy existing data if the file is already existing. Append mode will not destroy the existing data. It will start writing at the end of the existing data. Okay, so these are the three basic modes of opening a file. Now in any programming language, if you take this is common, so we can open file in different mode, normally read, write, append, etc. There are some few extension modes also. These are the basic modes R, W and A. Extension modes, here it will open only for reading, here it will open only for writing, here it will open only for appending or attaching data at the end. Now R plus will read the file for read and write operation. Similarly, W plus also will open the file for read and write operation. A plus also will open the file for read and write operation. Okay. So here writing will happen at the end of the existing data. Here writing will start from the beginning of the file. That means existing data will be overwritten by the new data you are going to write. Okay. In case of R plus, if the existing file is not existing, it will not create. Here if the file is not existing, it will create the file here it will not create the file if the file is not existing. Here also it will create the file if it is not existing. These are the 6 modes of opening a file. Okay, then corresponding to fopen, which will open the file or create the file depending on the mode, fclose is there, it will close the file. So if you have file pointer, so when you open you get a file pointer. When you open you get a file pointer. So when you call fclose, you pass that file pointer, the file will be closed. Okay, so opposite operation of opening a file. In between opening and closing, we will perform several read or write operations on the file. So we will see the other pairs of functions: getC, putC, fscanf, fprintf, getw, putw. Okay. So getC we have already seen an example. So the syntax of getC is used for reading a file from the file, character from the file, single character from the file, and the file is represented using the file pointer. So when you open, an address is returned and that you store in a variable called file pointer. This is the fp. Now if you want to read from the file, you don't need the file name anymore, just that file pointer is enough. Okay, here putC is handled first. Okay, we'll see getC first. So if you want to read a character, you call getC function and pass the file pointer. So the file should have been already opened using fopen, and you have the address or the pointer that is pointing to the file. You pass that into the getC function. You will get one character if it is existing. At least one character is existing in the file. You will get that, and that will be stored in the variable here. So you need essentially a character pointer, a character variable to which the character present in the file, one character will be read from the file and that will be stored. Okay. So any question is there, you can stop in between and ask any clarification is there. Okay. So assuming that h is a character variable, we get one character from the file into this variable. So in the opposite of getC function, that is putC function, right into the file. Here the syntax is the character variable which is having the character value that we want to write, followed by the file pointer. So this will write into the file. So getC takes only one parameter, the file pointer, and as a return it will give the character which is present in the file. If there are multiple characters, we have to keep on calling getC in a loop until all the characters are read, because at one point of time only one character can be read by this function. This function can read only one character at a time. So if there are multiple characters in the file, or it's a long string or a paragraph, you need to call this function in a loop. Now this function writes into the file a single character. So first one, the variable which is having the character data that you want to write, and followed by the file pointer. If you want to pass a character also, it is fine, character constant. So this will write a into the file. Otherwise, if the character is stored in a variable, it will write into the file. Okay, simple functions. PutC has two parameters, getC has only one parameter, which is the file pointer. PutC's parameters are the character that you want to write, followed by the file pointer, which represents the file to which you are going to write. Okay. So here it should be get the. So we have seen already an example program for putc and getc. So I read a character. We studied this function in second unit. It will read a character from the user, then we write into the file. Putc, the character variable followed by file pointer. But this one, if we want to use this file pointer, beforehand we should open the file, the file name, and the mode is write mode, and the address will be stored in this. If it is successfully opened, the address of the file will be stored in f1. That f1 only we have to use here. After writing just one character, I am closing it, f close, and the file pointer, f1 is the file pointer here, f close. And now I open the file in read mode and use getc function to read that single character just now I wrote, and I store it in D and I display it. After that I close the file I opened using a same pointer. I am reusing that pointer. I just use only one pointer, so I am reusing it here. Now the file is opened in read mode. Using that I am reading, then I am writing, displaying on the screen, then I am closing the file. So this time I will enter X. Now I same file which we had opened earlier, if you see, it is modified at 12:11. It is the current time, and I have only one character. So previously I had written G, that is overwritten. So this is as if the previous file was deleted and the new one is created. Okay, that is getc function. Any question? So we'll see one more example. Okay. Later, after seeing all the other functions, we'll see one more example. Now next function, pair of functions are getW and putW. Small variation to getC. GetW is used for reading an integer from the file. Integer data. If the file is containing numbers or especially integer data, getW can be used to read that from the file. So one integer will be read at a time. PutW is used for writing an integer into the file. Syntax is similar to getC and putC. In getW, you just pass the file pointer of an opened file, and we get one number as the one integer value if it is present in the array in the file, that will be returned. PutW, integer variable which contains the data that we want to write, followed by the file pointer. Okay, only one difference is there. getC and putC function, they are working on text files. Text file means when you open it, you can see the text or the characters. It is readable, it is human readable. But putW and getW, they are these functions operate on files which are binary files. Binary files means when you open it, how you can differentiate is when you open it, you will not have any readable content. Even though some data is present in that, it will not be a readable content, humanly readable content. Next example for binary file is your .exe file. If you open your .exe file in a notepad kind of application, notepad or textpad application, it will it will not be readable. See, this is an executable code of my file of my program, but when you open it, you don't find anything sensible actually, like it's not humanly readable. So such files are called binary files. Now another example for a binary file is your mp3 files or audio files or video files. They are binary format, because you cannot, you require somebody unmute, who is that? Or unmuted, who is that? Okay, Is it an indication that what all things you do when I am teaching? Okay. So yeah, put W and get W, they operate on binary files. So even though numbers are written into the file, when you open in a notepad kind of application, it will not be in a readable format. But using the function get W, we can read those numbers. So media files like video files, executable files of our program, audio files, they are normally binary files. We cannot open that file in a text pad kind of notepad kind of application and read the content. You need special applications like media player, video player, mp3 player applications to read and play the video or audio. Okay. So get W and put W writes in the format of binary file format. So we'll see an example. Similar thing, one number is taken from the user and written into the file. One number is taken from the user. Using fopen, we open the file. File name is data1. An extension is not necessary. If we want, we can give extension, or if we don't want. So since it is a binary file, I did not give an extension like .txt. .txt is something that when we open, we should be able to read the content. Okay, I'm just not giving it. I'm opening it in write mode so that a fresh file is created and it is opened for writing. And F1, on successful completion of this function, I get the address of the file, opened file, stored in F1, pointer F1. And the value I have taken from the user, I will be writing into this file using put W, then close it. After that, open the same file in read mode. Use getW function, pass the pointer and read the number, and that number will be stored in this variable number. Here I have two variables, num for getting the data from the user and write it into the file, number for storing the data that I am reading from the file and display it. So if I run this program, so I have entered a number, reading it back and displaying it. So entering number, writing into the file, then reading the data, file data is printed as 1 2 3 4 5. So we are reading it in fact. Now if I go into the go to the disk and see that, so data 1 is the file name. It is created now 12:17 p.m. and if I open it, it's a binary file. If I open it in text pad, so I'm finding something that does not make much sense for me. 190 is there, then null it is showing. So it's actually binary data. When we are trying to open, some of them are interpreted or misinterpreted and displaying some junk characters. So it's not readable, humanly readable data effectively. Okay. So that's about getW and putW functions, basically for dealing with integer reading and writing. Previously we have seen getC and putC for reading and writing characters, but as text file, and here binary files. Even though numbers are written, integers are written, it is in binary format, it is written. Now those were specialized function either for character data and or integer data. Now we have the pair of function that is generic in nature. You can use it for different data types, integer, character, double, float, basically basic data types you can use it for. fscanf and fprintf. Fprintf writes into the file, fscanf reads from the file. Now the syntax is similar to printf syntax, except that one additional parameter is there in the beginning. So in printf function we have a control string or format string and the variable list. variable or data list. These two parameters are there in printf. Here one additional parameter is as the first parameter we pass the file pointer to which we want to write. An example, if f1 is the file pointer and we want to write three pieces of data, one is a string, another is an integer, another is a floating point value, and string is stored in the array name, age is there in the integer variable age, and the floating point value we are passing a constant. So these three data will be written into the file represented by file pointer f1. Assumption is that that file is already opened. So fprintf just has an additional parameter compared to printf, that is also in the beginning, and the parameter is the file pointer. Otherwise the syntax of printf and fprintf no other difference. Fscanf similar to scanf function. Additional parameter is file pointer since we are reading from the file here. A normal scanf function is used for reading from the keyboard the input data entered by the user. Fscanf is used for reading from the file. Because of that we pass the file pointer as the first parameter. Okay, example is here. Now for reading a string, first I want to read a string from the file, so I pass an array. Item is expected to be a character array which can store a string, so I put %s. Second value that I want to read is a number, integer, so I use a integer variable and pass the ampersand with the as ampersand quantity. You probably, since you studied pointers, you must be able to understand why we are passing ampersand to scanf or fscanf. Actually we are passing the address of this function, address of this variable to fscanf, so that fscanf can store data there, and once we are back we are able to access that data. For that we are actually passing ampersand. When I taught scanf function, somebody had asked why in printf it is not required, scanf it is required, because we are calling by reference. So if any change is made to the variable, I want to get it back in my calling function, so I pass the address. Now it is called by reference. The changes made to the formal parameter will be reflected back in the calling function into the actual parameter. So we are actually passing the address to the scanf function, but printf we just want to get the data, so we directly use the variable name quantity. Okay, so fscanf is similar to scanf function, except that we use a file pointer since we are reading from the file in this case. Okay, now we will see an example for this. Here I am opening a file. I'm taking the file name also from the user. Okay, so far I was not taking the file name. Here file name is also taken from the user and stored in the array, character array file name. I ask the user to enter the file name. Now after that file file with the corresponding name I entered, that is I'm trying to open. So instead of passing a constant string constant, I'm passing the array which contains the file name. And since it is W mode, if the file is not there, it will create a new file. If the file is already there, it will destroy that file and create a new file. Okay, destroy the content of that file, and or effectively delete that file and open a new file with no content. Write mode. After that I am asking the user to enter a string, an integer and a floating point value. This we are taking from the user, string, integer and a floating point value, and then using fprintf we are writing into the file. So str1 I read here in scanf, writing into the file using fprintf. Int1 is my variable name, int1 is not a data type, it is my variable name, first number int1, and r1 is the floating point number I took from the user. All the three items I am writing into the file. Then I am closing the file. Open the file in read mode using the file name array, and using fscanf read those values. So string which I wrote here will go into str2. When reading I am using another array str2. Integer I am reading into int2. Floating point value I am reading into r2. See, I am reading from the file. I have passed the file pointer here. File pointer is created here using fopen, or initialized, or file pointer is assigned with the address of the opened file when I call fopen. And I'm after reading back I'm displaying str2, int2 and r2. Okay, so we'll just execute this. First a string, then followed by an integer, followed by a floating point number. So I made a mistake actually. First I should have given the file name. Instead of file name I directly started. So what is that? Hello.txt. So fscanf and fprintf, they work with text files. Okay, so it will create fopen will create a text file, and fprintf will write in text format. So this is the data we are writing into the file: a string, an integer and a floating point number. Then we are reading back, and when we are printing it shows the default precision 78 is shown as 78 followed by 4 zeros. 6 is the default precision. Okay, now if I go into the disk, go to the disk and see that hello.txt is created just now. Open it, you find the data there. Okay, so that is example for fscanf and fprintf. So three pairs of functions we are learning for reading and writing: getC and putC for characters, reading character getC, writing character into the file putC. Then reading integers getW, writing integers putW. One integer at a time, only one integer at a time. Then fscanf for reading different types of data, fprintf writing different types of data into the file. Then one last function that will be useful, that is FEOF. EOF stands for end of the file. FEOF is a function that will tell us whether we have reached end of the file by reading. When we keep on reading contents from the data, contents from a file, so every time when we are reading, if we are reading one character, we keep on reading subsequent characters. So by reading again and again, probably in a loop, one point of time we will reach the end of the file. That means all the contents are read. So if we want to check whether we have reached the end of the file by reading, we can use this function. FEOF will return true. True, 1 is the value used for true, as you know. So FEOF will return true if read operation has reached the end of the file. Otherwise it will return false. Okay, now if we want to read data continuously from a file, suppose a file is having lot of data, like a paragraph of text. So using getC we will be reading only one character at a time. So if we want to read all the characters, we have to repeatedly read. While reading it repeatedly, how do we read it repeatedly? We have to use a loop. One character at a time, we put it in a loop so that we keep on reading. Now we don't know how much data is there, so because of that, what we are going to try is FEOF we will apply. So we will apply FEOF. This is FEOF I'm calling with the file pointer. If it is true means, that means we reach the end of the file. So what we will do is, we will do not FEOF, not of FEOF. Okay, so if it is not end of the file, we will enter here. Not operation will simply negate what is returned by FEOF. So if true is returned, not of true will be false. We will not enter the loop. Here true returned means we reach the end of the file. We cannot read any more characters. So we should come out of the loop. So if true is returned by this, not of true is false. So this loop, when condition is overall condition is false, we will go out of the loop. That's what we are doing. No, if it is, or while not end of the file, we enter and read the character. Otherwise, we will go out of the loop. So this loop will keep on reading until the last character. After that, it will come out of the loop. So that is the use of FEOF. EOF stands for end of the file. F is normally like fscanf, fprintf to indicate that this is a file operation. F is here. Okay, an alternate mechanism is there. When we are trying to read without using FEOF, if we are trying to read from a file and that file is already reached end of the file, we will get a special value called EOF. Yesterday we had seen a special character null. The normally value is 0 to indicate nothing, no value. Null is a symbolic constant. Here EOF is a symbolic constant. Typically the value is -1. So if the file has already reached end of the file at end of it, and if you are again trying to read it, it will return -1 or EOF we call. So it is defined in one of the header files, normally maybe in stdio.h only, and its value is typically -1. We are not directly dependent on the value. We can just compare what is returned. C not equal to EOF, we can do the operation. EOF is an alternate mechanism. Normally we can use FEOF or EOF to check whether the file has reached. EOF is a constant, symbolic constant. The value is -1. And FEOF is a function which will give true or false. Okay, now we'll see some examples. This much is there. We'll see some examples for this. So we have seen basic example for get C and put C. Just read one character, write one character. Get W and put W, read one character number and write one number into the file. Fscanf and fprintf also we have seen. Read three pieces of data, name, number and real number, integer and real number. Write into the file, read it back. Now this is example for FEOF. We are going to read, what is it doing? Read some numbers. Okay, here this program, the assumption is that there is a file called data.txt and we are reading, there is some data in that. So data in the form of numbers. We are reading that data and finding the sum of the data numbers present in that. For that, what the assumption is, data.txt is already there. We are not creating it. We are just opening it in read mode. That means if the file is not there, it will return null. Okay, so let me see if file is there or not. Data.txt is not there. Okay, so if I execute this program, this will return null. Null stands for 0 normally, and I am checking fp equal to null. That means there is no file existing, and since it is read mode, it will not create the file also. It will create the file only if it is write mode. Okay, so if I run this program here, the output we will get is file open failed, because this condition is satisfied. File is not there, it did not open it or create it. The null is returned. I check for null value. If fp is equal to null, I am printing it. F file open failed. Now what we will do is we will create a file there. A new text file I will create, data.txt, and what I should put is I should put some values in that. Values should be integers. I am expecting that values are integers. And what I am going to do is read this content and find the sum of these numbers. Okay, data.txt is created. So what I am doing here, code while not feof, that means while not end of the file, using fscanf I am reading one integer, and where I am reading into, I am reading into an array. I created an array, maybe it will not create so large array. So I am initially I is equal to 0, I is equal to 0, index equal to 0. The first number I am going to store into array of 0, since I is 0. After that I am incrementing, I am finding the sum and incrementing it. Okay, we'll keep it simple. There is a variable sum which will store the cumulative sum of the numbers present. So sum is equal to sum plus array of I, or I have may return it using shorthand operator. Otherwise I can use simply this way also, sum equal to sum plus. So I am reading into an array. At the same time I am finding the sum of the numbers I have read from the file so far. And then since I want to read into the next read and store in the next location of the array, I am incrementing value of I to 1. So next time array of 1, at array of 1 it will be stored, then array of 2, etc. until when? Until the end of the file is reached. Okay, when feof is true, returning true, not of true is false, we will go out of this. Finally, when we are done with this, variable I will have the number of integers we have read from the file, number of integers which are present in the file. That is also, I is helpful in that way also. Now when I am going to execute this, and after that what I am doing is I am displaying all the numbers which I read from the file. I am displaying, it is now stored in the array, and this many numbers are there. I is assigned to size, so this many numbers are there. I am displaying all the numbers, and sum also I display, and finally close it. So these are the numbers we stored in the file. Where was that file? Data.txt. We stored, these are the numbers. All those numbers are read and displayed, and some of those numbers are also printed. Okay, so whatever numbers are there, all those will be taken. So if I add one more number or three more numbers and execute this program again, all those numbers are read, and sum of 1 to 10 is 55. So this is a useful, good application which will do all the numbers present in the file and compute the sum of it, store those numbers in an array, compute the sum of all the elements simultaneously, and finally display all those numbers and display the sum also. Okay, yeah, I think with that we will stop. Maybe there is one more example. Probably we'll see that in the next class and finish our uh, syllabus, and we'll have some general discussion in the next class. Okay, any question? If it is not there, we'll wind up for today.